Let's continue our studies of Samba implementation by focusing on the Samba server itself. So thus far we've looked at the clients, the important ones that is, find SMB through SMB tar. However, Samba server is the reason why we're here. It provides the ability to look like or interact with Windows servers as a Samba CIFS server. In other words, making your Linux or Unix box appear to be a Windows box on the wire. Its primary configuration file mentioned earlier is beneath etc samba, and it's smb.conf. This is where the key directives are placed. Now there is a program named SWAT, Samba Web Administration Tool, that is installed as a separate package, which manages the etc samba smb.conf file, which we'll be looking at to manipulate the directives that are important to us for our Samba server. But until then, we'll just take a look at the default configuration file and then move on to SWAT installation. So let's go to the shell, and on our local system, Linux CBT Serv 1, we'll navigate into etc samba lsltr, where you'll see two files, smb.conf and lmhosts. As mentioned, the lmhosts file is similar to, or functions similarly to, the lmhosts file within a Windows environment. It provides LAN manager resolution, so LAN manager names to IP addresses. The default file contains one entry for local hosts. Apart from that, there are no entries, but you could insert entries for LAN manager boxes on your network, and whenever any of your Samba related tools make a request that is to communicate with any of the systems listed in lmhosts through the Samba engine, they will consult lmhosts. By the Samba engine we mean whatever Samba client that's in use will make use of the lmhosts file. Apart from that, again, the key file is smb.conf, so let's take a look at it. We'll use nano space smb.conf. It's heavily commented, and the directives are well explained. Now in this global section that you see here, and the sections are denoted like sections in INI files in Windows, we see key directives that describe or define this system on the network when the Samba services are started. They include the all-important workgroup directive. If you recall from older versions of Windows, whenever you set up networking, you had to define a workgroup or accept the default of workgroup. Well, for this configuration, the default is mygroup. For other Linux distros, you may find that it's tux-net or tuxnet or something along those lines. The idea is you should have it match the workgroup or domain name that's in use in your environment. And again, from the shell, we're able to determine using SMB tree that the workgroup is Linux Genius. So with that said, we will change our workgroup setting to Linux Genius. The string that's returned here is just that. It's a text descriptor that's returned and displayed whenever you query the Samba server from a Samba client, such as Windows or Linux. So it's just a descriptive string. And again, the commented line before the uncommented directive explains the purpose of the directive. And also, as is common with most Linux text files, configuration files, hash marks denote comments. Security mode. Samba operates in multiple modes: user, server, Active Directory, and so on. Those are the three key modes. In user mode, you need to have a Samba user defined for every local Linux user. Let's just note some of these things. Samba server modes. And these are the key modes, not all of the modes. User, server, ADS for Active Directory, which allows your system to participate in Active Directory. In user mode, one Samba defined user is required per Linux user. And there's a way, or there's a means for defining Samba users that translate to local Linux users. Ultimately, Samba provides access, file and print access, and in granting file access, Samba needs to speak Windows language, which is a different language for authentication. The passwords are kept using a different algorithm, and it needs to translate those users using its facilities to local Linux users who can be looked up in etc password and etc shadow. So in user mode, one Samba-defined user is required per Linux user. Also in this mode, authentication is handled by the Samba server. So authentication of user or users is handled by Samba server, which means when a user connects to your Samba server, the Samba instance consults its database of users and translates those users to local Linux users. In server mode, it will list server/domain, which is another mode. That's similar to server mode, but in domain mode, the authentication happens by any, or is performed by any domain controller. But in server mode, as well as domain mode, either mode, authentication is handled by the Windows NT 2K, 2K3, 2K8, or what have you, server. However, it still requires, in server mode as well as domain mode, the requirement is still there to maintain a local user account database. Still requires a local Samba defined, as we mentioned above, user account database. In ADS integrated mode, authentication is handled by the Active Directory setup, so it's handled by Active Directory. And in addition, when coupled with WinBind, when used with WinBind, locally defined Samba users are not required. And that's because WinBind has a facility to allow remote users to log in and take advantage of Linux services. In other words, it provides a translation between the remote users and local IDs. It automatically assigns IDs, and we'll look at that when we get to the WinBind section. But for now, we're focusing on user and server setup to authenticate locally as well as via a server. The server could be an XP box, NT, 2000, 2003, 2008, you name it. These are the main modes: user, server, Active Directory. Server and domain function similarly, but again, in domain mode, multiple servers such as a PDC, BDC, Windows system may authenticate requests, whereas in server mode, a specific server known as the password server is responsible for authenticating the connecting user. But when it's all said and done, let's just note, ultimately, with regards to providing access to files and printers, but particularly files, but printers are also files, ultimately, users must authenticate to the local Linux file system. So they must pass the test of gaining access to files within the Linux file system. The permissions must be granted, whether it's via WinBind, and we use the chown facility or change mod to allow WinBind users access to directories, or whether it's via a local Samba-defined user accounts database which maps out to a local Linux user. The user ultimately has to be granted access to the local file system. Otherwise, Samba will prompt, and the user will be then asked to specify appropriate or valid credentials. So with that said, let's continue perusing smb.conf. Samba has many features, including the ability to restrict connectivity to its services to specific IP addresses. This option is currently commented out, but if you'd like, you could restrict communications with your Samba server to specific subnets. And here we see examples of how to indicate multiple subnets. 2 RFC 1918 and 1 loopback subnet. Whether or not printers are to be loaded, it's set to yes by default. Print cap settings, the printing engine defaults to cups. Cups accepts the job in raw format, so it should be already set up by the application that's sending the job to be printed, or it needs to be in the appropriate form for the printer to print the job. Guest account, and it's suggested that you uncomment this if you want to support a guest account. And if you do want to support guests, guest will be translated to nobody, which is an account in the Linux world, which is equivalent to anonymous. However, you can define your guest account to be whatever you'd like it to be, but generally it's not a good idea to enable guests. It's better that you allow each user to connect distinctly. For each connecting Samba client machine, a log file is created with the machine's IP address or its host name, and it's created beneath varlog Samba. Earlier when we were discussing logs, we did mention that Samba maintains its own directory hierarchy beneath varlog because it has the potential to house many, many files depending on the number of users that connect to your Samba server. So this variable %m means to Samba to record the name of the file using the machine's IP address or its host name. And that way you can determine what connections were made by various clients in your environment. The maximum log file size is set to 50 kilobytes. In a busy production environment, this is not practical. It should be much larger, such as maybe 50,000 megabytes or 50 megabytes per connecting users if you really want to keep track of the resources that have been accessed by connecting clients. Whether or not to use a password server. And this is a mode that's used when you set security equals server. Again, when security is set to server, you're basically saying you want a given server to cross-reference user connections. It still doesn't exempt you from having to maintain a local user account database for translation purposes, but the onus of confirming credentials is then placed on the server that's referenced by the password space server equals directive. In the case of domain controllers, password server equals asterisk will work because it means any server, PDC or BDC or any number of BDCs that are able to respond will suffice. But in the case of a single server, such as an XP or 2003, 2008 server, then you need to indicate that server, and you'll still in either case need to maintain a translation locally on the Linux system, which we'll get more into. If you're using Active Directory, you need to specify a realm which usually maps to the Active Directory domain name, which is usually some form or some derivative of your DNS infrastructure, such as linuxcbt.internal or ad.linuxcbt.internal. Now, we've been talking about the local user accounts database. It's stored using, by default, a format known as TDB-SAM. This is the default format that will be used when we use the SMB password utility to create and modify and update local user account mappings, which ultimately get translated to local Linux users. Interfaces. You can determine which interface Samba or interfaces Samba should listen to. Another neat feature, because often you find with Linux systems that they are multi-homed, meaning they have multiple physical interfaces, and you may or may not want Samba to be available on